Good. Thank you for the invite. Very, very happy to be with this group. A lot of this group I've known and read your work, so I'm very excited and impressed to be here. My name is Corey Scott. I'm a principal nutrition scientist with a company called Cargill, which is headquartered in the United States. And I'm going to give you an industry perspective on how we work with added sugars, but more specifically with low and non-caloric sweeteners. So these are just my disclosures. I'll start off by just describing Cargill in one slide. People have heard of us, maybe people haven't. Cargill is a major company that supplies pretty much any type of food ingredient to the food industry. We don't do business to consumer, we do business to business. And we market proteins, we market lipids, we market carbohydrates, but I'm going to be talking today specifically about low and non-caloric sweeteners. We have over 160,000 employees. We have offices in 70 different countries. We've been in business for 158 years, and we have a very large annual revenue. So let's talk about high-intensity sweeteners. I think we've already heard a lot about high-intensity sweeteners and the job that they do. I'll just define them as sugar substitutes that are several hundreds, if not several thousand times as sweet as sucrose. As a matter of fact, they should be called high-potency sweeteners, not high-intensity sweeteners. They supply the same amount of sweetness that they just do it at sometimes even an order of magnitude less on a mass-by-mass basis. Although these sweeteners do the same job, they are very diverse molecules. And I put some of the names, you've seen these names before in talks already, of the different type of sweeteners, but they're very diverse. They are diverse in their chemical structure, they're diverse in their sweetening potency, they're diverse in their stability, they're diverse if they're artificial or plant-based, some are protein-based, they're even diverse in how they're excreted and absorbed and the sweet receptors that they act on. This graph that I like to show here, this is a sweetness intensity curve. It may be difficult to see, but the sugar curve, when you taste sucrose, you get a sweet taste that goes away. But high-intensity sweeteners don't follow the exact same curve. The onset of sweetness may be faster, it may be slower, the linger may be longer. So it's very consistent in the industry to actually combine these sweeteners to get a taste that matches sugar perfectly. Hasn't been done yet, but they get really, really close. Even though they are diverse, the industry actually speaks of sweeteners as an entire category. Very rarely do you see one sweetener speak out against another one, or rarely do you see them mentioned not in the same category as well. And I'll talk about that in a few more slides. So there's been a huge recent media focus on high-intensity sweeteners. I think in general, I'm very comfortable saying that high-intensity sweeteners are probably the most scrutinized food ingredient that exists. And these are just headlines that I pulled from the last 6 months. These are headlines that are talking about sucralose damages your DNA, erythritol, which is not a high-intensity sweetener, but it is indeed a sweetener, causes heart disease. And I do want to make a reference here to 1970s cartoon Scooby-Doo, who you may be familiar with. Why this recent focus on sweeteners? Sweeteners have always been scrutinized, and they've been in the diet for about 40 years. But we really think we're seeing this resurgence of the scrutiny is, let's see who you really are. At the end of the show, they would pull the mask off, and you would see who was committing the crime. And we've heard a lot about ultra-processed food and ultra-formulated food. That's probably why. Even if you have something and then you add a sweetener to it, it will typically fall into this category. So that's likely why we're seeing this renewed interest in sweeteners. So John has already talked about some of the recommendations. I won't go over those, but the U.S. Dietary Guidelines recently did acknowledge the benefits of adding low and non-caloric sweeteners into the diet, specifically to manage weight and lower sugars. He also talked about the World Health Organization, where it was a tale of two different stories. The randomized controlled trials in the short term show benefits for low and non-caloric sweeteners and no safety issues, but the longer term cohort studies show a different story, and the World Health Organization recommended to go with those type of studies rather than the randomized control studies. We didn't mention yet, but JECFA and IARC, these are two agencies that are also under the World Health Organization. They did a reevaluation of aspartame, and they just published these about a month ago. Both of them looked at the same set of science, but they came with two different conclusions. JECFA sets an ADI for sweeteners, so all sweeteners have an acceptable daily intake. And in a nutshell, they basically found no safety issues with aspartame when they reevaluated all the evidence, so they kept the ADI the same. IARC looked at the same set of data, but also some carcinogen data, and they classified it as a class 2 carcinogen. So again, this is just more of the controversy with sweeteners. And then EFSA is reevaluating a number of sweeteners as well to maybe reset the ADI or maybe not include them in their approvals. So what does the industry do when you see the media reports, you see the publications, you see the recommendations? How do we respond to this? Well, we do this a number of ways. The first thing we do is we critically review the study. A lot of times we will get an embargoed study a few days before it's released. We'll get that from the researcher, we'll get that from a media outlet, and we will take a critical and fair look at the study. Maybe it's telling us something that we didn't already know, and we want to know everything about our ingredients, so we'll take a critical and fair look at the study. We will also monitor the media pickup as well, and this is just a graph of the media pickup. These are things that we do. They're done internally and also externally, and you typically see 2 blips. So the first blip, and this is social media, this is newspaper, magazines, networks. You typically see a huge blip. The news cycles typically last 48 hours, then it goes down, and then you see another blip. And the reason why you see 2 blips is this is more of the sensationalization of the paper here. And then it dies down, and then when experts get a chance to read and review and critique the paper, you'll see another blip here, and they commonly tell 2 different stories. So it's very atypical for a company to go out on its own into the media because there are many manufacturers of these sweeteners, and we want to make sure we align with the same message. So we typically put our message out through trade associations. And these are a number of trade associations that represent both the entire food industry, consumer packaged goods industry, ingredient suppliers like ours, and we actually speak through them as well. And we align with them and their experts, and they have a lot of experts like academics, and we align on a message and we get it out. And this is an example of a message from the study, recent study on sucralose that was done by Calorie Control Council. We all reviewed the paper, and we all came out with a message. And this is what gets put out about the studies that way. So these are the ways in which we typically respond. So now I'm going to switch gears a little bit. We want to know more about our own ingredients. And as Cargill, of the high-intensity sweeteners that exist, we manufacture 2, stevia and mogroside. So mogroside is a monk fruit extract. So those are 2 plant-based sweeteners that we manufacture. When you take something like stevia was approved for use in 2008, so it hasn't been on the market very long. There's a wealth of information on many of the artificial sweeteners, but on stevia, there's not a lot of human clinical studies. So I'm not talking about the regulations or the toxicological studies. I'm talking about randomized controlled trials. So this was a gap analysis that we performed in our company, and the objectives were to fulfill any significant research gaps. This may be a little difficult to see, but this is what's called an alluvial plot. So what we did was we looked at the number of studies. We pulled all the stevia randomized controlled trials. We looked at the populations that were studied, healthy, diabetic, overweight. We looked at what was their primary objective. And you can see here as these studies flow, you can see this large band in postprandial blood glucose, fasting blood glucose, which stands to reason. That's the job that the stevia does, is replacing sugars. So we want to see the effects on glycemia. And then the duration of the study. And you see a third of them are less than a day, a third are 1 week to 2 months, and a third are 2 to 6 months. But what you don't see is you don't see effects on gut microflora. You don't see effects on gut-brain axis. So those are big things that we wanted to study. So I'm just highlighting the recent industry-funded research that we did. We did publicly register all these studies on clinicaltrials.gov. Some of the studies, we put the protocol out and published that before we did research. We try to be as transparent as possible. The studies that I have highlighted in yellow are studies that have already been published. So we did do a study on stevia and glycemia that we published. We did a study on stevia and food intake. If you have a diet beverage, you're saving maybe 100, 150 calories. The question is, will that cause you to eat more during the day? And we did a study to understand if that's true or if that's not true. We just finished a study in March on the effects of a very high dose of stevia on gut microflora. We're going to finish a study on September 20th, a couple of days, where we're looking at stevia and appetite hormones, so the gut-brain axis. We published a study on stevia and brain responses. We did this against water and sugar. There's certain areas of your brain that light up due to sweet taste, that light up due to calories. And we want to understand if stevia has a sweet taste but no calories, what areas of the brain does it light up as well? And then we just registered a study last week on clinicaltrials.gov. We're doing a study of stevia in children. And our primary objective there is weight management in children, but also several safety parameters as well. Yep. 1 minute? Okay, good. So We fund our own research, but we also partner in research as well. So I do want to highlight two large European consortia. The first one is Project SWEET. This is a 5-year, 10 million euro project that's funded by the European Commission. The question they want to answer is, if they replace sugars with low and non-caloric sweeteners in the diet, what does that look like from a health and safety standpoint, from an economic standpoint, from a regulatory standpoint, and then will consumers accept it? So a very large study that's going to end in October of next year. And then Project iSense looks at sweetness in the diet. So this doesn't have anything to do with low and non-caloric sweeteners. Sweetness itself is under attack. And what does that mean if you can vary the level of sweetness of the diet? What does that look like for overall health? This is my last slide here. Some of this I won't go over because John has talked about this, some of these as well, but high-intensity sweeteners have existed in the diet for a long time. They have a long history of safe use, and they have global regulatory approval. They're useful tools for reducing sugar. Concerns and controversies do exist, mainly between the trial types. As the industry, we want to learn more about our ingredients, and we're transparent in the way that we do research, and we really want to find out what our ingredient is all about and what all of it's doing. And we do that in a number of ways, through consortia, through our own funded research, and we also work through trades.